Geologically speaking, Mars might still be alive. Numerous recent Marsquakes have been examined by scientists who have demonstrated that they are most likely the result of magma moving beneath the Martian surface. The researchers write about this in an article published in Nature Astronomy on October 27th. NASA's InSight lander has discovered more than 1,000 Marsquakes since it landed on Mars 4 years ago. Its seismometer captures seismic waves, which provides details about the size and location of the trembles. Hello science lovers, and welcome back to Theory of Science. To know more about how mysterious Marsquakes hint at a volcanically active planet, continue watching the video. Scientists believe that a plume of searing hot rock coming from close to Mars's core may help to explain recent volcanism and earthquakes there. The plume is as large as the continental United States and may be related to the red planet's core. Geologists have long yet been aware of mantle plumes on Earth, despite the fact that this is the first mantle plume that researchers have discovered on Mars. For example, the Hawaiian island chain was created as the Pacific tectonic plate progressively migrated across a mantle plume. Unlike the nearby rock, the material in the mantle plume is buoyant. Similar to how hot oil rises to the top in a lava lamp, it is lighter, thus it floats and migrates upwards, according to Brochet. Large monuments like Olympus Mons, the largest peak in the solar system, and other enormous structures were left behind by Mars's early 1.5 billion years of volcanism. But for the past 3 billion years or so, most scientists believe Mars had cooled and had been lifeless. But in recent years, geologists have detected signs of geologic activity after all, and now they have discovered a mushroom-shaped pillar of hot, buoyant rock beneath the Elysium Planitia region that may just help to explain the recent discoveries. According to research by main author Adrian Brochet, a planetary scientist at the University of Arizona in Tucson, our work shows that Mars is not dead. With the discovery of evidence in 2021 that Mars may still be volcanically active and that there has been eruption signals within the last 53,000 years or so, the story around the planet's recent geology started to alter. That study found a previously unidentified smooth, dark volcanic deposit covering an area just a little bigger than Washington, D.C., using information from satellites orbiting Mars. The Cerberus Fossae, an 800-mile-wide system of juvenile fissures, are surrounded by a deposit that surrounds one of the cracks that makes up the system. This region is within the northern lowlands near the Martian equator, the Elysium Planitia, a generally featureless plain. According to earlier research, numerous Marsquakes have originated in the Cerberus Fossae region of Mars. The InSight lander is located more than 1,000 kilometers away from this area, particularly rife with faults. However, according to Anna Mittelholz, a planetary scientist at Harvard University, most of the Marsquakes connected to Cerberus Fossae have been quite scientifically well known. Their low-frequency seismic waves look a lot more like what we had witnessed with an earthquake, she claims. Since then, Mittelholz and her colleagues have examined a sizable sample of Marsquake, including more than 1,000 high-frequency temblors that differ significantly from their earthly counterparts in appearance. The researchers combined their rather weak signals in order to better comprehend the cause of the high-frequency Marsquakes. The quantity of seismic energy emanating from the direction of Cerberus Fossae peaked in a stack of seismic waves, according to experts. Provate Carley, a geophysicist at the Australian National University in Canberra, who was not involved with the research, thinks that it was quite a remarkable undertaking. This investigation is the first to try to find high-frequency earthquakes. On our own planet, earthquakes of magnitude 4.0 are large enough to feel beneath your feet, but not dangerously so. Nevertheless, InSight's success is comparable to having one car-sized probe land in West Texas and having it find a number of relatively mild earthquakes outside of Los Angeles. According to InSight Deputy Principal Investigator Sue Smrekar of NASA's Jet Propulsion Laboratory, we've observed evidence for volcanic flows, faulting, and fluvial flows, water on the surface, within the last 10 million years in the Cerberus Fossae. Our earthquakes that we have so far been able to find are in that region. It's interesting because we wouldn't really anticipate recent volcanism in that region if we use a simplistic model of Mars's thermal evolution. As they learn more about the specific type of geologic activity occurring in the Cerberus Fossae, it should also provide hints about the variety of volcanoes in the area of Mars, she added. After that, there was still shaking. In the end, InSight detected a staggering 174 seismic occurrences on Mars. The Marsquakes could be divided into two groups. 24 were big and far away from InSight, and the rest were smaller and clearly had higher wavelengths, indicating they were propagating closer to the surface. So guys, what do you call a comet wrapped in bacon? A meteor! Make sure to subscribe to the channel if you haven't already. While a second plume might be hidden beneath Tharsis according to Broquet, he believes that Elysium Planitia was only the area on Mars with an active mantle plume. The largest volcanoes in the solar system are located in Tharsis, a region on Mars that is 3,000 miles wide and located close to the equator. Scientists have discovered recent and ongoing volcanic activity there, he added. He said that there might be other causes for the volcanic activity in Tharsis besides a mantle of plume. For example, because the crust is so thick, heat may have been trapped and helped keep the rock there molten. In contrast, the crust is known to be substantially thinner in the Elysium Planitia region, where we detected the plume, and so we had to invoke another mechanism, that is, the plume, to induce the volcanism, he said. The mantle plume, which he raised in the Martian crust by more than a mile, has sent hot magma to the surface of the red planet and is responsible for the Marsquakes that InSight has detected. Not only is there new volcanism in this region, but we can also tell that it's the result of a recent uptick in activity, according to Broquet. The last significant volcanic activity in this area occurred approximately 3 billion years ago, so something else might happen there to trigger his volcanic revival, and that something is the mantle plume, according to Dr. Smith. It surprises me that there are so many different kinds of earthquake clusters in one area. Previous studies have hypothesized that Marsquakes may result from the surface of Mars cooling and shrinking over time. According to Mittelholz, the anticipation was that Marsquakes would originate from all over the place and be distributed evenly around the planet as a result of that mechanism, which occurs regularly on the Moon. As of now, Earth's seismic activity away from the plate tectonic boundaries appears to be comparable to that of Mars. Furthermore, the significance of these earthquakes goes much beyond the novelty value of merely being aware of their existence. Mars turns out to be crumblier than we thought. The best explanation, according to researchers, is ongoing volcanic activity. New techniques have discovered earthquakes beneath the Martian surface that were previously undetected. Seismic activity has been a major source of information for geologists concerning the interior of our own planet. Seismic waves encounter various densities of materials as they pass through the interior of the planet, changing their speed and direction. Therefore, NASA's InSight lander provides a window into the interior of the red planet with each signal it sends back. The evidence seems to be piling up that Mars is far from dead and really conceals an interior vibrating with seismic activity beneath its dusty, lifeless surface. The information is also illuminating Mars's magnetic field and atmosphere. The localized magnetic field surrounding InSight is 10 times higher than anticipated based on satellite studies, according to NASA students who were astonished to discover this. According to Catherine Johnson of the University of British Columbia, a mission co-investigator, this suggests that there are magnetic rocks beneath the InSight landing location. InSight should develop a better understanding of the underlying geology beneath the spacecraft as the Marsquakes continue and what's happening within the Martian crust, and much deeper. According to NASA, the lander is expected to function for an additional year. The researchers further demonstrated that the low-frequency Marsquakes are likely created by magma moving several tens of kilometers beneath Mars's surface by contrasting the seismic waves that InSight observed with the seismic waves produced in various places on our own planet. Mittelholz claims that our results are significantly more consistent with data from volcanic zones on Earth. The researchers has come to the conclusion that Mars may be remarkably dynamic rather than being a geologically dead planet as some have claimed. According to Mittelholz, this discovery completely rewrites our view of Mars, and there is yet so much more to discover about our planetary friend. We are just getting started. And that is all for today, guys. So what do you think? Let us know in the comment section below. If you like this video, then please give it a thumbs up and smash that subscribe button for more content like this. Hit the bell icon to receive notifications, and also check out our channel for more exciting videos like this one. We'll see you in the next video. Until then, goodbye.